Okay, we've explored triangles that are similar. Now we're going to look at how to prove that triangles are similar. Looking at the first item on your notes, angle-angle similarity. It basically, they say if two angles of one triangle are congruent to two angles of another triangle, then the triangles are similar. Well, why do you think that could be? Let's take a look in this example where we're actually going to show that these two triangles are similar. I'm going to find angle A. So I said 52 plus 81 has to add up to 180. And I solve for angle A. Well, okay, 52 plus 81 is 133. And I subtract 133 from both sides, so I get A equals 47. If A is 47, that matches with F. And you can see if I have 47 degrees and 81 degrees, for a triangle, the other angle would have to be 52 degrees, and that's what this one is. So this would be 47, that would be 52, and that would be 81. So in reality, I have all three angles are congruent because all three have to add up to 180. As you might remember, if you had two angles congruent, that's enough for the third angle theorem. Therefore, since I know that angle A and angle F are congruent, they're both 47. Angle C and angle H are congruent, they're both 52. I actually only need to show two angles because the third angle comes naturally. And therefore I have angle-angle similarity. When I ask for a similarity statement, that's a lot like having a congruent statement, except I use the similarity symbol. So in this instance, I have triangle ABC is similar to triangle FGH. Now another idea we have is side-side-side similarity. If the three sides of one triangle are, before we were doing congruent triangles, but now we're doing similar. Do we need the sides to be exactly the same? No, we don't. We need them to be proportional to the three corresponding sides of the other triangle. Then the triangles are similar. So I'm going to take a look at these two. Here are the corresponding sides, and I've set up a ratio between the corresponding sides. This is really the best way to do it. Then you have, there's DF is to JL, EF is to KL. Now when I substitute in the values for the lengths of those sides, I have 8 is to 16, 6 to 12, and 10 to 20. All of those simplify to 1/2. So they're all equivalent ratios, so all of these are proportional. Now if you accidentally set up where you do DE and DF and then KJ and JL, that will still work because remember proportions can be rotated and it'll still work fine. Now they ask for the similarity statement, which is triangle DEF is similar to triangle JKL. Our next one is side-angle-side similarity. Now we had side-angle-side could prove two triangles congruent, so I don't need the sides to be congruent, I need them to be proportional. But I still need the angles to be congruent, the included angle, the angle between both the sides. I'm looking at this picture here and I went ahead and redrew it. So now I have MN and MP here, and I filled in the 8 and the 4. Here I added the 8 and the 4 and I got 12, and I labeled the 6 here. The one thing they give me to start is that these two angles here are congruent. So I'll go ahead and write them out. Angle NMP is congruent to angle RMQ, and that's given to me by the arc marks. Now I'm going to go ahead and look at the ratio, and I'm actually looking at the ratio in the triangle, but remember proportions you can rotate. So I'm looking at 4 to 8 and I get 1/2. Let me look at the other one. 6 to 12 and I get 1/2. Since the ratios are equivalent, then it is proportional. And if they're proportional, then I can claim side-angle-side similarity. And the last but not least in your notes, it asks for the similarity statement. Make sure that your corresponding letters go together. So it should be MNP is with, typo, is with, let's see, MNP is with MRQ. So you fix that, MRQ. All right? Now let's look at some properties of similarity. The first one should look familiar, reflexive property of similarity. We used to have or we still have the reflexive property of congruence. And that was like saying angle A is congruent to angle A. Same idea, angle A is also similar to angle A. In this case, we'll say triangle ABC is similar to triangle ABC. For the symmetric property of similarity, we just reflect it. It's symmetrical, so we switch it. A triangle DEF is also similar to triangle ABC if triangle ABC is similar to triangle DEF. The transitive property of similarity is kind of like a transitive. It has to do with transport, and it's kind of like you go triangle ABC is similar to DEF, triangle DEF is similar to triangle XYZ. Then I can take the shortcut and go all the way from triangle ABC to triangle XYZ. And that is the transitive property of similarity. On example 4, they want to know which similarity explains a triangle AED being similar to triangle ACB. And also they want me to find the length AB, which is, by the way, why this X pops up later. First of all, the thing I can see is they marked angle E and angle C congruent, so that's given. But I also look at angle A. It's shared between the two triangles, and by the reflexive property of congruence, and I think I put similarity, but by the reflexive property of congruence, they actually are congruent. So I have two angles that are congruent, and I'm going to fix this right here so that says congruent instead of similar. So since I have two angles congruent by angle-angle similarity, the two triangles are similar. Now I need to find the length of AB, which is this orange piece right here. Well, I'm going to go ahead and set up a proportion between the sides, between the two triangles. So I'm going to say 6 is to 9 as x plus 6 is to 15. Now, why do I have x plus 6? Well, I went ahead and put my x on this little piece instead of the whole thing, although I could have done the whole thing. And I said, okay, if this little piece is 6, then this long piece is x plus 6. Then I cross multiplied. So to cross multiply, again, just to review, you have 6 times 15 is one of the cross products, that's on the left here, is equal to 9 times x plus 6. Once I multiply that out and distribute that 9, I get 90 equals 9x plus 54. Then I set up my equations and I see 90 equals 9x plus 54. Subtract 54 from both sides, I get 36 equals 9x. Well, if 36 equals 9x, then x has to be 4. Therefore, I'm trying to find AB, which is the sum of x plus 6, so I plug in 4 for x, and I get 10. Example 5, they want to know which similarity explains triangle UVW is similar to triangle YXW. Well, first of all, let's take a look. They tell me that these two are parallel. These extra green and the red angle marks, I've added them myself. You can see this one right here I can do right away because those are vertical angles. These two, angle U and angle Y, are alternate interior angles because this Y is a transversal and lines UV and lines XY are parallel. When you have a transversal and parallel lines, alternate interior angles are congruent. So I can say that these two angles are congruent because of vertical, and these two angles are congruent because of alternate interior angles. That means that my two triangles are similar, again by angle-angle similarity. Now I need to find this green length, WY. I'm going to go ahead and set up a proportion, and I'll say 9 is to the corresponding side over here. 9 is to WY, as 7 is to 8.75. Go ahead and cross multiply. So 9 times 8.75 is going to be the same as 7 times y. They are equal. And I set up this equation. Now, I'm trying to solve for wy, so I'm going to divide both sides by 7. And then I get, using my calculator, that the length of wy is 11.25 or 11.25. Last but not least, we have example 6. On example 6, they say that MN is parallel to KL. Let me go ahead and take the liberty of adding some marks here because it does help when you're doing proofs to add the marks. They want me to prove that triangle JMN is similar to triangle JKL. So the first thing they write in the proof is that MN is parallel to KL. That's part of our given. Then they say angle JMN is congruent to another angle. And so here's angle JMN, and they say it's congruent to another angle by the corresponding angle postulate. Well, the corresponding angle is right there. So JMN is congruent to JKL. Now they say that JNM, I'm going to put 2 angle marks here. Notice how I mark it as I go through. Is congruent to JLK. And the reason I can say that is those are also corresponding angles. And because of that, I can say the 2 triangles are similar because I have 2 sets of angles that are congruent. That's called angle-angle similarity.